All right, welcome. In this video, I'm going to be going over 6 basic trig ratios. And so the objective of this video is that you're able to identify the 6 basic trig functions on a right triangle and use this trigonometry to solve a right triangle. So let's go ahead and get started. This is a right triangle, and in our right triangle, I've labeled the angles and the sides. Now, normally when we look at a right triangle, the angle A is directly opposite the side with the lowercase a. And the angle C is normally our right triangle. And directly opposite from C is the side C. This is often called the hypotenuse. And the hypotenuse is always the side opposite the right angle. All right, we're using theta as our reference angle. So if theta is our reference angle, then our side right next to the reference angle, next to, is adjacent. And all the way across is the opposite. All right, so whichever angle you're using, that's what you're looking for: adjacent, opposite, and hypotenuse. So the 3 trig functions that I think you already know because you've done it in geometry. If not, you've got 3 functions. They're the sine, the cosine, and the tangent. And we get this nice little memorization tool, SOHCAHTOA, to find the ratio of these sine, cosine, and tangent. So what this says is that the sine is equal to the opposite over the hypotenuse. So the sine of theta is right here, is the opposite over the hypotenuse. And in this case, the opposite is B, and the hypotenuse is C, so this would be B over C. All right. Make sure you have something in the sign, because this is not, it's just not sin. You know, you have to have sine of something. Okay, so here's cosine. So cosine of theta is the adjacent over the hypotenuse. And in this case, it's the adjacent A over the hypotenuse C. And then we have the tangent. And the tangent is the opposite over the adjacent, which is opposite, which is B, and adjacent, which is A. So B over A. Now we have 3 other trig functions, trig ratios, that go along with sine, cosine, tangent. And those are secant, cosecant, and cotangent. Excuse my awful handwriting here. So the cosecant, and it's abbreviated by CSC, the cosecant of theta is actually the reciprocal of the sine. It's 1 over the sine. So if it's the reciprocal of sine, in this case, it would be C over B, or the hypotenuse over the adjacent. The secant is the reciprocal of cosine. So in this case, C over A. And then the cotangent is cot, C-O-T, is the reciprocal of tangent. So in this case, A over B. And those are the 6 basic trig ratios. So let's say we had a triangle. We had a right triangle, and we want to find all of these trig ratios for the right triangle. So let's take a look at that next example, or I guess our first example. So we've got a right triangle here, and we want to find out, we want to write all the 6 trig ratios. So one of the things that we're going to need to do before we do that is we're going to need to make sure that we know what this side is. Okay. Oops. So this side right here, come on, pen. So we're going to need this side right here. And we know this is our right angle, this is a right triangle. We're going to need Pythagorean theorem. So 20 squared plus 15 squared. This is actually a Pythagorean triple. 20 squared plus 15 squared, and we find the square root. We're going to get 25. So now we can go and write all those trig functions. So let's go ahead and do that. We're going to write sine, cosine. So sine of, I should have labeled this. We'll do theta again. So sine of theta is the opposite over hypotenuse. Okay, so katoa. So 20 over 25. That's it. Okay. Cosine of theta is the adjacent over the hypotenuse. Tangent of theta is the opposite over the adjacent. Cosecant of theta is the reciprocal of sine. 25 over 20. Secant of theta is the reciprocal of cosine. 25 over 15. And cotangent of theta is the reciprocal of tangent. That's all there is to it. All right? Okay, so what if we're given a situation in which we want to use one of these sines and cosines and tangents in order to solve a side, a missing side, or a missing angle in a triangle? Okay, so let's say we have this problem that says solving a right triangle. So what does it mean by solving a right triangle? Well, solving a right triangle means find all missing sides and angles. So if we were going to solve a right triangle, and angles, we're going to want to find all the missing sides and angles. And what I want to do here is I want to draw a right triangle with this given information. So we're going to go ahead and draw a right triangle. Okay, so best right triangle that I could possibly draw here. And we're going to label, I always label C as my right angle. I don't know what little c is. I do know that angle A is 25, so this is my angle A. This is 25 degrees. My side B is 5. So remember that across from this angle is the little one. This is B. And across from this is little b. So little b was 5. All right, so I know this angle. I know this side. I need to know these two sides. Now I can find this angle too. So angle B, we simply take 90 and 25. And remember that the sum of the angles in a right triangle are going to be equal to 180. So we do this math real quick. Okay, so 180 minus 90 minus 25, 65 degrees. So we got the last angle here. Now we need to find these two sides. Okay, so I know this is 65 degrees. You can use either angle as your reference angle. I'm going to use 65 because that's what we used in the last example. So I'm going to go, I need A. I have 5. So which one of these trig functions am I going to need to use to find A? Well, this is the opposite and this is the adjacent. So the one that uses opposite and adjacent is tangent. So the tangent of 65 degrees is the opposite over the adjacent. And now I'm going to solve this. And I can solve this by multiplying both sides by A and then dividing by tan 65. So 5 over tan 65. Now we're going to want to use a calculator to solve that out. Okay, so we grab our calculator and we can make sure your calculator is in degree mode. And you do tangent of 65 times 5, or I'm sorry, 5 over that. Okay, which ends up being around 2.34. Okay. So now we have this side. We can use Pythagorean theorem if we wanted to, but I'm going to continue using trig. So now I'm going to go opposite over hypotenuse. Opposite over hypotenuse is the sine. So opposite over hypotenuse. So multiply both sides by c. And then divide. Okay, and then again I'm going to plug that in my calculator. 5 divided by sine of 65. And I'm going to get about 5.52. Okay, and that's it. So I've solved. I found C, I found side A, and I found angle B, which means I solved this triangle because I did all the sides and all the angles. Why don't you try this one right here on your own, and then pause the video and then come back and see if you got the correct answer. Okay, so I'm going to draw a right triangle again, and I want to make sure that I label this correctly. So this here is going to be my C. It's 90 degrees, of course. B is down here. It's 42 degrees. And then A is going to be right here. It's 5. And now I want to find side C, I want to find side B, and I want to find angle A. So angle A can be found by taking 180 degrees minus 42 minus 90. And that will give me my my angle A. Which would be 48 degrees. All right, then I want to find side B. So this is, again, I'm going to use tangent here. So the tangent of, wow, that's fun. The tangent of 42 degrees. Hopefully you can still see this, guys. I don't know what happened to my computer here. Here we go. Tangent of 42 degrees equals the opposite over adjacent, opposite over adjacent. And this time all we have to do is multiply both sides by 5. And we're going to get 5 times the tangent of 42. So I'm going to go to my calculator and make sure I have it in degree mode. And I'm going to get about 4.5. And then I'm going to find side C. So I'm going to use the cosine this time. Cosine of 42 degrees. Because I want the adjacent over the hypotenuse. So C is going to be 5 over cosine of 42. And this I got, remember, I multiplied by C divided by cosine of 42. So I'm going to have 5 divided by cosine of 42. And any scientific calculator will do this for you, but I will show you how to do this in the TI Inspires. Okay, 6.73. But again, any scientific calculator, even the ones on your phone, can do this work. Okay, so there you go. That's it. That's solving right triangles and using the 6 basic trig ratios.